All right, let's continue with section 1.3. We didn't quite finish it the last time, and so let's finish it up. Let's do multiplication, right? We did addition, we did subtraction. Remember, you can only add like terms, and subtraction. If you have a minus sign outside of a parentheses, you distribute the minus sign through the parentheses, and then you just do basic addition, right? Make sure you only add like terms. Multiplication, you can multiply things that don't have like terms. And so let's do this. I mean, this really is an Algebra 1 topic, and you really hit it big time in Algebra 2. Let's change all this stuff so I can write with it. But somebody asked me the other day, what would you consider college algebra? Oh, is it like an Algebra 2 class? I said, I don't know. I'd probably call it like Algebra 2.5. Kind of, you do the same kind of principles. We'll learn a few different things that you didn't learn in Algebra 2, but we'll actually cover many of the topics that you did in Algebra 2. So some of it, for some of you guys, it'll just be review, but for some of you guys, maybe that's why you're in here, because you didn't do so well in Algebra 2. So this is a good chance to get that refresher course, and get a good solid foundation so that when you do get into college, you can have a good understanding of your basic Algebra 2 type of concepts. All right, so anyway, here we go. Write this down. So it's 4x squared. Then I have a parentheses. There's no plus or minus in between here, okay? So that means it's being multiplied. And then you got a few things in here. You got 3x cubed plus 2x squared minus 5x plus 1. All right, so there you go. And it tells you to, it says find each product. So it says product. Product means you multiply. It's the answer to a multiplication problem. So, I mean, some books would just say simplify. Some books might say evaluate. There's all kinds of different instructions they could give. But basically, what are you doing? You're just multiplying those things together, right? So you take that 4x squared and you have to multiply it by everything inside that parentheses. Because it's outside the parentheses, that means you multiply by everything inside the parentheses. I do this a lot. Now, you wouldn't have to do this for every problem, but I just do this as a teaching tool. You take that thing on the outside, you multiply it by the first term. Then you take the outside times the second term, the outside times the third, the outside times the fourth, and if there was more, of course, you would multiply it by the rest of them. First, actually, before I start, I should look at all the stuff in the parentheses. If there were like terms, if there were things that you could add together inside the parentheses, I would do that first before you run right into the distributive property. So let's just take a look. I got x cubed, x squared, x, and a 1. Well, there is nothing inside there I can add up. There's no like terms that I can add inside the parentheses. But I would always look for that. I kind of doubt they'll give you too many where you actually can add some like terms in there. They're probably just concerned about the multiplication. But you always need to look to see if you can simplify the stuff in the parentheses first before you do the multiplication. It's order of operations, isn't it? Please excuse my dear Aunt Sally, you do parentheses first. So first thing I do is I say, is there anything that I can simplify in the parentheses? No, there's not. Not on this particular problem, right? So now we can multiply through. What property do we call that? I don't think I said it yet today, or maybe I have. Distributive property. Very good. Okay, so let's do this. Multiply these two things together. Well, the number's out in front. What was the big fancy word which starts with a C that I said was that big number? It's coefficient, right. So you multiply the coefficients together. Just multiply them straight up. 4 times 3, and that's just 12. Now, we learned a rule the other day about multiplying same bases with exponents, didn't we? So you keep the base the same, and what do you do with the exponents? Add them up. So that's x to the fifth, right. A lot of people would say x to the 6th. But I've had people say, oh, it's x to the 6th, Mr. Hamrick, it's multiplication. 2 times 3 is 6. But that's not the rule, is it? The rule is, for multiplication with exponents, that you add the exponents together. It's not an addition problem. It's still a multiplication problem, but you add the exponents. Okay? Let's keep going. 4 times 2, that's 8. X squared times x squared is x to the 4th. Good. Minus 4 times 5 is 20. X squared times x to the 3rd, or x cubed. Yeah, we wouldn't say x to the cubed. We would just say x cubed or x to the 3rd. All right, and then plus 4x squared times 1 is just 4. Good, 4x squared. All right, there's no other like terms in here. You can't add anything together, and that's it. That's your answer. Big crazy looking answer. Now that doesn't really, it's not a real practical type of problem. It's probably not a problem that you would actually see in real life. But what it's doing is just teaching you the skills to be able to do other problems. you probably won't have a job where you have to sit down and solve one distributive property and that's it, and you get the answer and you can solve all the world's problems, okay? That's not how it works. But this is just one little piece of the puzzle, because there are problems, when you get up into higher math levels, there are problems that will require a whole bunch of steps, 4, 5, 6, 7, 8, 9 steps. And one of them might be a distributive property, all right?
And
so you need to know how to do it.
You might have to plug the answer to that problem into
That's
another
right.
problem.
I mean, there's all kinds of stuff that you could do with this, okay? This is just one little piece of something you may do later on that could be a very practical problem that you could do. I taught physics for a lot of years at my other school. Physics is a very, very practical use of the math that we learn, okay, in high school and college and all that kind of thing, all right? So there are definitely courses where this will come in handy, and then you need to know how to do that. All right, so what did we multiply? We multiplied this. Remember we gave names to these polynomials? What's a polynomial? What's the name of a polynomial with just one term? It's a monomial. Now what would this thing? Well, this doesn't even have a special name, does it? Because there's 4 of them. Because we stopped at what? What was the? We stopped at trinomial. So we just say this is a
quadrinomial?
Well, I guess you could say that, but we just say it's a polynomial, okay? A 4-term polynomial. So if I'm taking monomial, multiply a whole bunch of these, that's just regular distributive property. Anytime you have a monomial, one term, times a whole bunch of other terms, you're going to use distributive property. But what if, I'll just make this one up, what if we had a binomial, right? That's 2 terms, times another binomial. All right?
Foil.
Right. A lot of times we learn the word FOIL. I used to teach out of a book at my other school. They never mentioned the word FOIL one time. Okay, they always talk about distributive property. They never mention the word FOIL. Now, I'd always bring it up because I kind of learned it that way. A lot of teachers teach the FOIL method, right? You've all heard that before, I'm sure. Arturo, you probably never heard that, did you? FOIL? Yeah, you didn't. This is what it stands for. The F stands for first. Okay, F-I-R-S-T. Okay, that means you're going to multiply the first terms together. Basically, it's just distributive property. The O is outside, or some people say outer. I like to see just outside. Okay, the outside terms. What do you think the I stands for?
Inside.
Inside terms. And then the L is if this is first, the L is last. Okay, so it's just it's a word that just lets us remember first, outside, inside, last. We call that a mnemonic device. You ever hear of that? Okay, so that's what we use right there. So what does that mean? Basically, like I said, the other book never mentioned the word FOIL, because you only use the FOIL method under one certain particular circumstance. The other book just said distributive property, like this. We took the thing on the outside, we multiplied it by everything in this parentheses. Look at this one. We're going to take the 3x, multiply it by everything in that next parentheses. Do you see that? So that's 2 multiplication problems right there, isn't it? 3x times 2x, 3x times -7. Then what else do you have to what else do you have to do on the distributive property? Take the second thing, right? We haven't multiplied this by anything yet. So let's take this and multiply it by everything in that other parentheses. So basically, FOIL method is just distributive property, isn't it? All right, just take the first one, multiply it by 2 things, take the second one, multiply it by these 2 things. So it's just a fancier distributive property. But for some reason, I think our book, even if you look in the book, I think it will say FOIL method in this particular book. You don't have one in front of you, okay? But in your Algebra 2 book, Algebra 1 book, you did this in Algebra 1, they probably use the word FOIL. But really, it's just distributive property. So it's the first one times both of these, it's the second one times both of these. So let's do it. The first one times this first one, right? That's the first. So 3x times 2x is 6x squared, x times x. A lot of people, not a lot, but I've seen several people forget to multiply the x and the x. They do the 3 and the 2, but for some reason they forget the x times the x. Make sure you do that. All right, let's take that 3x times the next one. So it's 3x times, you got a minus right here, so it's a -7. So 3x times -7 is?
-21.
Very good, -21x. All right, so that's the first and the outside. Do you understand the outside? 3x and the -7 are on the outside of my parentheses. Now we do the inside, or you just take that 2 and you distribute it through both of those things in that parentheses. 2 times, they're both positive, so you put a plus. 2 times 2x is 4x. And then the last, okay, or that 2 times that -7. 2 times -7 is -14, so you put -14. Now right up here, we circled the whole thing and we were done. But down here, do you just circle the whole thing? Are we finished now?
No.
No, not yet, because you always look to see if you can add what?
Like terms.
Are there any like terms here?
20.
Yeah, there are.
21x and 4x.
You got it. Negative 21x and 4x. So you can add those. Up here, there were no like terms, were there? But I looked to see, though, didn't I? Remember we talked about it? I said, make sure you look. See if there's any like terms to add up. There are none here, but there are some here. So make sure that you add the like terms together. So it's 6x squared, because there's no other x squareds. But these two are like terms. Negative 21x plus 4x is, what's that? Negative 17x. Okay. And then minus 14. There's no like terms here, are there? Because this is x squared, x, and just a regular number. When it's just a regular number with no variable next to it, we call it a constant. All right, you ever hear that? So it's just a regular number, we call it constant, because it always stays the same. 17x could change depending on what x is equal to. Agreed? And so 6x squared could change depending on what x is equal to. It doesn't matter what x is. Negative 14 is going to stay negative 14. So we call that a constant. And I'll use that word a lot. And there you go. That's how you do that.
You're constantly using the word constant.
That's correct. All right, so what did I multiply? I multiplied a binomial times another binomial. All right? So what if we do this? Let's change colors. Let's go this blue, a little darker. Let's try a binomial times a trinomial. Let me find a good...
There's one on our homework.
No, I'll leave that one for you. I don't want to spoil the fun.
I'll read that.
Okay. Let me find... Oh, here's a good one. So here's a binomial. Yeah, they would do this. Okay. So it's 2x minus 1. That's in parentheses. So there's a binomial again, just like we started off. But this time, we have 3 terms inside of here instead of 2. So you can't really use FOIL method, because FOIL method only works when you have a binomial times a binomial. But we can still think of it as distributive property. That's kind of how I'd rather you think of it, is just think of it as distributing. All right? So what do? We take that 2x, and we multiply it by everything in that other parentheses. Then we're finished doing that. Then what do we go to? The negative 1. It's not just a 1. It's a what? It's a negative 1, and we multiply it by everything inside there. So really, how many multiplications are we going to do? This number times 3, and then this number times 3 of them. So we get how many? 6 different multiplications we're going to do on this. Make sense? All right, so let's do it. I'm not going to draw all those arrows. It kind of gets in the way. So let's just take that 2x, multiply by all 3 of these terms. So 2x times negative x cubed. That would be negative 2x to the 4th. Good, because this is x to the 1st. We add the exponents. Good to go. All right. Let's do this 2x times the 3x. Both positive, so that's positive. 2 times 3 is 6. X times x is x squared. Good. Now let's take the 2x and multiply by this last term, this constant right here. It's a positive times a negative, which will give you negative. 2 times 4 is 8. And then what do you have? You got an x. We're not finished, though, are we? So that was the 2x. Now we have to take this negative 1. Now be very careful with this. This is where a lot of people mess up. This is not just a 1, it's a what? It's a negative 1. So make sure you take that negative 1 and distribute it through all 3 of these. A lot of students forget to do that. So it's negative 1 times negative. So negative times negative is positive. So that's the first thing I deal with. Now 1 times x cubed is just x cubed. Good. Negative 1 times this is negative 3. Notice what it's doing. All it's doing is just changing the sign and keeping all the rest of the stuff the same, isn't it? All right, because it's a 1, and it's multiplied by negative 1. Negative 1 times negative 4, that's a positive 4. There you go. Are we finished? Do we just circle it? No, always look to see if there's like terms. Well, you got an x to the 4th. Any other x to the 4th?
No.
Nope. What about x squared? Nope. What about an x?
Yeah.
Yeah, I got an x right here and right here. So I can add those together. Do I have any x cubes? Just that one. Any other constants? Nope. Let's put it in order. We call it, when we put it in order from the highest power all the way down to the lowest power, we call that descending order. Descending starts from the highest and it goes down to the lowest. You've heard that before, haven't you? Have you heard of descending order? Let's write it in descending order. Now, do you have to? Will I mark it wrong if you don't? Nope, I won't. All right, but it's just nice. It's a little bit more orderly, I think, to put it in descending order. Unless the problem asks you to do that. I think other books I've seen, some books will say make sure your answer is in descending order, and if you didn't do it, then it would be wrong, right? Because that's what the instructions say. But in here, I won't say put it in descending order. You can put it any order that you want, but it's so much nicer if you do put it from the highest power down to the lowest. So that's the highest power. What would the next highest power be?
Positive x cubed.
How about x cubed? X cubed would be the next one, right? It goes from the fourth to the third to the second to the first to the constant. All right, that's what I would do. So I'd put x cubed in here, plus x cubed. Sometimes I'll mark them off when I know I'm done with them. All right. What's the next term I want to put in here?
6x
Good, we got the 6x squared, so I'm done with that. Now I can add these two together. Negative 8x minus 3x is negative 11x. Right, now you don't put x squared, do you? Because you're adding like terms. You keep the term the same. All right, it's not the same rule as multiplication. Adding like terms, you just keep the term the same and add the coefficients. We're done with that. What's left? A plus 4. And there you go. You got a nice, neat little answer. It's in descending order, looks real nice. Everybody will be consistent with our answers. And then that's all there is to it. Make sense?
Yeah.
Alright, cool. We're moving right along, aren't we? Let's go to yellow. Check that out. Wake us up a little bit. So we did a binomial times a trinomial, right? We did a binomial times a binomial. We did a monomial times a whatever nomial. So let's
Next is
go 3 and 3. Let's go a tri times a tri. How's that? Wow, we're getting fancy now, aren't we? So let's do this. We'll use different letters then.
Wunderbar.
Look how nice and bright that is. Isn't that pretty? So, yeah, sure it is, Mr. Henry. Whoopie-doo. Tell you what, I'll let you have some fun on this. You just try it yourself, and then we'll see if we all get the same answer, okay? So I'll give you like 2 minutes. Ready? Go. Alright, time's up. That was a quick 2 minutes if you watch the video, because I just paused it. So let's do this. Let's take the m, we multiply by everything in here. Then we'll take the negative n, multiply by all 3 of these, and we'll take the k, the positive k, and multiply by all 3 of these. So let's do it a little quick now since you've already given it a shot. So m times m, that's m squared. M times 2n is plus 2mn, right? There's really nothing you can combine there. You just put them next to each other. And then the m times this, it's a minus. 3's out in front, always put the coefficient first, and then mk. Now, does it make any difference if you go mn or nm or mk or km? No, it doesn't make any difference, okay? Whatever's first, I put first,
So
okay?
if there's an exponent involved, that does make a difference.
Yeah. So let's do the, so that's the m. Let's do the negative n, multiply that through everything. So negative n now times this. So that would be negative mn. This would be negative 2n squared, and this would be positive 3nk. Alright, so that's the second one. Now we take the third one and multiply it by all 3 of these. Plus, we could put n first, then m, but look what I've done so far. I put mn, so I'm going to go mn. I'm sorry, I lied. I looked at the wrong thing. It's k, isn't it? I was thinking n again. Alright, it's km, so let's put km. Or mk, let's put mk. Alright, and then plus 2nk. Plus 2nk. And then minus 3k squared. Minus 3k squared. So look at that. 9 different terms there, isn't there? Alright. Now we got to go through and see what's going on with our like terms. Let's take a look at the first one, m squared. Are there any that's exactly m squared? Nope. So I just write down m squared. What about the mn? So I'm done with that one. Mn. Yep, there's one right there. Is that all? Yep, that's the only one. So 2mn minus 1mn is plus mn. Alright, so I'm done with those. See how nice it is when you have a whole bunch of them to mark them off? You see that? Mn, that's the only other mn's. What about mk?
Yeah,
Yep,
there.
this one right here. Okay, so negative 3mk plus 1mk. Negative 3 plus 1 is? Negative 2. Good. mk. Done with that. What about just an n squared? Any other n squareds? Nope, so I'm just going to put minus 2n squared. So I'm done with that. nk. Yep, right here, there's another one. 3nk plus 2nk is 5nk. Right? Because 3 plus 2, you're adding like terms. Keep the term the same, keep the letters the same, just add up the coefficients. So that goes and that goes. And then a k squared, there's no other k squared, so you just write minus 3k squared. Now I know I did talk about descending order, but you do have like 3 of these that are the same powers. I would just keep it like that, okay? I don't see any reason to rearrange that. We've added up all the like terms that we could, and there you go. So this is how you should be doing the problems. Now you're using a worksheet, so I'm not going to make you rewrite the problem unless you're doing it on another sheet of paper. If you're doing the problems on another sheet of paper, rewrite the problem, show all your steps, that's your work, okay? That's all your work, and then put your answer down, circle your answer so I can see what your answer is. We good with that? All right, let's do one more thing. Let's go this orange. That looks lovely. What if I said this, 3 squared? What does that mean to say 3 squared?
9.
Okay, what does it mean, though? Not the
3
answer.
times
3 times 3, exactly. So 3 squared, if I square something, it means 3 times 3, which, Tiffany, is... How's your chance? Okay, 9. All right. So when you square something, what are you doing to it? You're multiplying it by itself. Okay, that's what you do. When you square something, you multiply it by itself. So if I had 3x squared, let's do that. What if I had 3x to the 5th, and I had it in parentheses, and I was going to square it? So that means I have to square everything inside that parentheses. Would you agree? So I have to square 3. So 3 squared. We can do that in our head. What's that? We just did it. It's 9. But then I have to take x to the 5th, and I have to square that. What's the rule for squaring an exponent? Or for taking an exponent to another exponent. Multiply the exponent. So this is going to be what? X to the 10th. All right? So there you go. So you know how to square something. If you wanted to, you could always have done like a middle step. I wouldn't do this. Okay, I think it's a little too time consuming. But you could have said, we talked about sneezing before. I'm about to sneeze. Better watch out. Wait a minute. All right, it's going away. Don't you hate that? All right. Okay. Now if I was by myself, I'd just let it rip. But I'm trying to be nice to you. So if you square something, what do? You multiply it by itself. Would you agree?
Yeah.
Now, this is not the most practical, efficient way to do this problem, but I'm just going to show you that it works. So you could multiply it by itself. So what are you doing? You're going 3 times 3, which is what? 9. X to the 5th times x to the 5th. What's the rule there? You add the exponents, so you still get 10. You still get the same exact answer, don't you? So wouldn't you agree multiplying it by itself is the same thing here? But what if you had something like this? What if you had x plus 2? And you had a squared here. Now look at this and look at this. Are they the exact same style of problem? No, it's not. What's the big difference on this problem as opposed to this? The plus sign, okay? So a lot of people mess up on this. A lot of people, and I hate to even tell you what other people do wrong, because for some reason it seems like I'll say, a lot of people do this, and it's not right. But here's the right way to do it. A lot of people will remember the wrong way to do it instead of the right way. So I almost hesitate to do this, but I'll do it anyway. A lot of people will do this. They'll say, oh, you just square everything in here. X squared plus 2 squared. It kind of looks like what you should do. And people call it distributive property. Well, there is no distributive property with exponents. Okay, there is no property that says, oh gosh, I hate to write this, but you cannot... Watch. You cannot, that means does not equal, okay? You cannot say a squared plus b squared. That is wrong, wrong, wrong. Scribble it out. I almost hate to even write that on there. You cannot do that. There is no distributive property with exponents. Right, Norval? You getting all this? All right. Why don't you get your head up a little bit? That might help.
It's basically...
All right. So you can't distribute it. What do? What did we just say that you do right here? What do you do to a number when you square it? You multiply it by what? Itself. Remember that. When you square something, you multiply it by itself. So, going with that whole idea of squaring something, if I multiply this by itself, what does it need to look like? It needs to look like x plus 2 times what? X plus 2. That's super important right there. That is a huge roadblock students have. So if you get it straight now, it should be pretty easy after a while. You cannot distribute this squared through there. It doesn't exist. Distributive property does not exist with exponents. People look at this and say, yeah, but you did it here. Mr. Emery, you said you can't distribute, but you're distributing here. This is not really a distributing, is it? All you're doing here is just taking everything to the second power. There's no plus or minus in between. All right? It's not distributive property. This is not distributive property. What are you doing? You're squaring it. You're multiplying it by itself. Now you can work this problem because we already talked about that. FOIL method or distributive property. Let's do it real quick. X times x is x squared plus these two. The outside is 2x. The inside is also 2x, and then the last terms are 4. All right, simplify this. That's right, add the two common terms together. That's a 4x plus 4. Now that is your answer right there. Okay, that's different than if you would have just gone to x squared plus 2 squared, isn't it?
Yeah.
You missed a whole entire term there. All right, that makes it way, way different. So you got to make sure that you do that. So when you have parentheses and you have a plus or a minus in between and it says to square it, you got to make sure you write it down twice. Remember, squaring something is multiplying it by itself. All right, if you can remember that, then you're just like, okay, I'm going to multiply it by itself. Oh yeah, it's just a regular FOIL method, and then you go through the FOIL method. We good? All right. I think we covered everything on that page. Is there anything on that page that it looks like we didn't cover? I think.
Find the degree, but like.
Does it say find the degree? Sorry about that. I didn't mean to put that on there, but that's okay. We'll talk about finding the degree. Let's pop up here. Finding the degree means you take the term with the highest, with the most exponents. Okay, the highest number of exponents, and that's the degree of this polynomial. So, for instance, which of these terms has the highest power?
Negative 2x to the 4th.
X to the 4th, right. X to the 4th is the highest power, so we call this a 4th degree, oops, forgot the D, 4th degree polynomial. All right. What about this one right here? Well, this has a squared, that has a squared, that has a squared. So what's the highest power here? It's 2, right. So we call it a what? Second degree polynomial. All right, that's all that is. I'm not really all that concerned, but you said there is a problem on your worksheet that asks that? Okay, so that's basically what it's asking. What if you had this? What if you had like 3x squared y to the 5th plus 2x y to the 3rd? Let's find the degree of this polynomial.
Okay.
Now, that's the highest power, but the whole term, though, if I added up all the powers of that one particular term, how many powers would I have?
7.
I'd have 7. How many would I have here?
3.
No, because it's x to the 1st. This would be 4 of them, right? So this would be a 7th degree polynomial. All right, makes sense? I should have counted these right here because that would be a 2nd degree polynomial, right? That would be 2nd degree because of those two. So really, every one of these terms is 2nd degree, isn't it? So that's the highest that it is. We just call it a 2nd degree polynomial. All right. I think. What do you got? Like one problem like that or two, maybe? What is that? Let me see that one. Okay, you could do number 2. Leslie asked about number 2, so let's take a look at it. I'll do that problem for you. That's 2 to the 9th over 2 to the 7th. A couple ways you could do this. You could figure out what 2 to the 9th is, but that's some big old giant number, isn't it? You could put it in a calculator if you wanted to, but here's a better way to do it. And I think we forgot about this. You remember the product rule where it says x to the 3rd times x to the 5th? What do you do with the exponents? Keep the base the same and you add the exponents. What about division? It's called the quotient rule, and I should have mentioned this and I completely forgot. You subtract the exponents as long as you have the same base. All right, so you keep the base the same, you subtract the exponents. So 9 minus 7 is 2. You can always simplify that. That's easy enough. That's just 4. Okay? So that's the rule for, that's called the quotient rule. Everybody good?
Yeah.
All right. All right, if you have any questions on these, go to YouTube. If I went a little fast, if you didn't quite get it, you can always go to YouTube, pause it, rewind it, watch it a couple times. You don't have to watch, look, we're at 29 minutes now. You don't have to watch the whole entire video. Just get to the point where, you know, you might have, maybe there was like 2 problems you didn't understand, or I went a little fast. Just go to those problems. You don't have to watch the whole entire thing. Okay, that's it. Just finish up that worksheet. I'll collect that whole worksheet tomorrow, okay?